Stuff. All right, so yesterday, or not yesterday, a couple days ago, when you were doing simplifying, now you're going to do multiplying and dividing. All right, we got to do all of the operations, but we're going to do actually the easiest ones first because adding and subtracting is actually the harder concept, so we're going to do those last. All right, so multiplying and dividing rational expressions. You've got some steps. All right. So when you're trying to figure out what exactly you're going to do with your expressions, if you have something that has addition, subtraction symbols in it, the first thing that you want to do is make sure that you factor everything. So you want to factor the numerator and denominator. Okay? So again, that's only if you have adding and subtracting, because that's the only time you can really kind of go backwards and factor out a GCF before you can simplify. All right. If you don't have an adding subtracting, then you're just going to do what the previous notes were, which was to cancel common factors, because that's the second step you're going to do here. So you're going to go cancel common factors. At the very end, if you still have multiple fractions written, you're going to write all of your factors you have left as a simplified fraction. So that's going to be your last thing. So write remaining factors as one fraction. Now you don't actually have to multiply them through. Okay, so if you have a monomial and a binomial, I don't want you distributing it and making it look like some long, nasty polynomial. I'd rather you just leave it, and I'm going to show you what I mean when you're doing your notes today. Okay. So a couple little examples. So now, part of this on your exam is going to say, perform the operations. Just like it did when we were doing adding, subtracting, and multiplying before at the beginning of the year. It's just going to say perform operations, and you got to know what to do. So we've got 4a to the fourth over 3. And I want to take that fraction and multiply it times 6 over 5a squared. All right, so I'm multiplying two fractions together. And when you're dealing with multiplying fractions, your goal is to simplify common factors from any numerator and any denominator. Does not matter which fraction it comes from, because the commutative property of multiplication allows you to manipulate where the factors are sitting as long as they stay in the bottom or stay in the top. Right? So I can take a 3 out of this fraction and a 3 out of that one. All right, I know I said free. A 3. All right, so I can simplify across fractions. There's no equal sign there, so I can simplify across. And then the same thing with the a's. All right, I've got 2 in the bottom here, and if I take 2 from the top, there's 2 left. I can't do anything else with that. All right, they're the 2 and the 4 that are up top have to stay there. So the only thing I have left would be to write my remaining factors as a fraction. So in the top, 4 times 2 is 8. And then I have a squared. And in the bottom, I'm just left with that 5. Those are the only pieces or the only factors that I have left. Right? And so that's what you're going to do when you see fractions like this, which have not just numbers but variables. You're just going to start simplifying either top and bottom of the same fraction or diagonally across fractions. And then you're done. You're done with that one. This one is done. You're done. You will have a big fat test just for that, yes. Right. Right. All right, so I'm going to make it a little harder then, since you think that was super easy. There you go. That's a little bit more like it. All right, so that actually looks a little bit more like there's one side of that yellow worksheet where you had stuff that looked like that. No one liked it. Okay, so here's the deal. Leave this first fraction alone for right now because you can't really do anything with it yet. Like I can simplify that down, but I want to wait on it for a second because I don't want to get confused with what I'm going to do. So what I need to do is I need to factor the top and the bottom. All right. Now, this one right here is a difference of squares. It's just flipped from what we've talked about in the past. So other types of difference of squares you've done is when it's like x squared minus the perfect square, and this is flip-flopped. So what I want to do is I want to modify this a little bit, and I want to write this in descending order instead. So I'm going to just change the order. I'm going to cross this out because I'm just making it look different. So instead of it being in the order of 49 minus x squared, I can flip-flop it and put a negative in x squared plus 49. What you want to do is you want to factor out this negative because we don't like negatives in front of an x squared when we're trying to factor. So on the top here, if I take out a negative 1, what I have left is x squared minus 49. So if I want to be able to flip-flop the terms like that, right, and take out the negative 1, now I can factor this as a difference of squares. Right? It's the only way that you can really do that when you've got a negative in front of the x. Right? Actually, I should have put that up here. That's okay. All right, so I'm just going to write everything down. Since I'm using pen, I made a mistake. It's okay. All right, so I still have to deal with this. I haven't done anything with that yet, but I'm going to leave it there for a second. All right. What about the denominator? All right. Well, we can write this as two binomials. All right. And this is kind of the easier of the ones where a is 1. You don't have to do an area box if you don't want to. All right, but really what you're doing is you're looking for factors of negative 14 that add up to be negative 5. And I'm going to use negative 7 and positive 2. And so right now everything is almost all the way factored. Bless you. All right. So I factored. What do I have left to factor? I still have to factor this piece right here. So I took out the negative 1, but I still haven't written it as factors yet. All right. And that one comes from that video and from some of the other notes we've done where I've got this perfect square. This one right here is the same thing as x plus 7 times x minus 7. Right. And so what I'm doing is I'm crossing out that binomial I have and rewriting it as 2 instead. All right. So anytime you have a perfect square minus a perfect square, you can write it that way. But you have to take out the negative first, otherwise you won't have the subtraction sign. And now you can go through and start canceling out anything they have in common. So like this x minus 7, I can cancel out with the 1 from the denominator now. I can't do anything with the x plus 2, the x plus 7, or that negative 1, but I can simplify the numbers in front down here, and I can take a 4 out of both. And I can take this x to the 4th out and change this one because it means I'll have 4 left. So the only bad thing about having to do these ones is that you've got a lot of crisscrosses happening. And so you have to figure out what your final answer is going to be. So you need to look up at the top and see what you have left. I have a negative 1 and an x plus 7. All right, so just leave it alone. Don't worry about trying to multiply it through. It's just going to make your life harder. And then in the bottom, you've got this random 2 sitting here. Plus you still have 4 x's in the bottom and this x plus 2 in the bottom. That's as far as you can go because there's nothing else in parentheses that's in common that you can cancel that's identical, and there's nothing on the outsides number-wise or variable-wise that you can cancel. So it's going to get a little bit more complicated now. Yeah.
How did you get from 4x to the 4th power over 8x to the 8th power to 1 over 2x to the 4th?
So the way that you simplify this piece down here is very similar to what we worked on a couple of days ago, where you want to simplify the number portion. So like between 4 and 8, I can factor out, I can take a 4 out, and so I'm left with only a factor of 1 up top and 2 in the bottom. And then with your rules of exponents, the exponent tells me I've got 4 x's sitting up top and 8 in the bottom, and so it means I have 4 left in the bottom. So I just took the 4 out of the top and the 4 out of the bottom and said how many more are still left in the bottom.
All right.
And that's where you get the x to the 4th.
Thank you.
Yeah.
So when you get the 1 over 2 to the fourth power, you just multiply it to the 2x plus 7 over x plus 2.
Yeah, you're just looking at the top because it's still a multiplication, and you're just writing any factors that are left and putting it as one product, as one fraction. So like here is 2x to the fourth times x plus 2. So that's the same thing, 2x to the fourth times x plus 2. Yeah, because I don't want you to multiply it through. I want you to leave it like that. So just leave it that way. That's where you're done. Right? All right, so let's look at this one. All right. So they're going to like kind of change a little bit here and there just to give you a variety of different types that you can see. All right. I mean, variety is good here. So the x plus 2 and the x plus 3, all right, those don't have anything in common. You have to think about having invisible parentheses around those two factors, all right, because they are separated by addition and subtraction. Then I can't cancel the x's or anything like that. They're connected. All right, so anytime that you have just two terms, nothing in common, they're still contained together. So my job is to sit here and factor this side right here. So again, I have a difference of squares. So that's an x plus 1 and an x minus 1. And then same thing down the bottom. That's another a equals 1 sort of scenario from module 6. And so factors of 2, I can only use 1 and 2. All right. And then I still have these other two factors. So I'm putting them all in parentheses so that way you can see how they're all contained together. Because if it's a binomial, it has to be stuck together, like handcuffed. All right. So as long as you can cancel out a common binomial, you're good. So x plus 2 and x plus 2. The x plus 1's cancel. And so whatever factors are left up top, you're going to keep it up top. Whatever is in the bottom, you got to keep in the bottom. And you can put the little parentheses around them if you like. And so there's one thing that we have not yet talked about. We're going to go through and we're going to start adding some stuff to our answers. When we were simplifying on Tuesday, when you're canceling out common factors, anytime you cancel out a variable, you have to put your restriction. And I haven't put any restrictions on any of these, right? But we need to go back and do it. You know, I've been so focused on factoring, I forgot my restrictions. So let's go back and look at number 1, or letter A. All right, so the only variable I canceled out was the A, and so I need to add the restriction that A cannot be equal to 0. Right? So those two fractions are equivalent given, or with the condition that that variable that was in the denominator that I canceled could not be a 0. Right? I cancel out the A. Right? I need to figure out when that factor I canceled out is equal to 0. The only way is there's nothing to solve. If A is equal to 0, bad things happen. So I have to put that condition over here that this product is equivalent to that fraction given that A cannot be equal to 0. I can't put a 0 in the denominator. So remember from the other video that we watched, every time you cancel out something from the denominator, you have to know when is that going to be equal to 0. Right? Like over here, when we canceled out x's, right? It doesn't matter how many x to the power I canceled out, right? I have to know that x could not be equal to 0, otherwise bad things happen, right? I cancel out x to the 4th power.
Okay.
Well, when is x to the 4th power equal to 0? The only time that is ever going to happen as a true statement is when x equals 0, right? You got to do the same thing for this one right here. When is x minus 7 going to be equal to 0? When it's 7. You're just setting it equal to 0 and solving. Those are the two values I can't use. I can see there's other values I can't use, but when we're talking about the restriction the other day, all right, if I cancel out a variable, you have to know when that variable or variable expression is equal to 0 because that's a restriction. It's when you always cancel something out. Like over here, what did I cancel out on letter C? I canceled out an x plus 1. So when is x plus 1 going to be equal to 0? When it's negative 1. So I can't use negative 1. When is x plus 2 going to be equal to 0? When it's negative 2. So those two values are restricted. It looks like I could use them here and still be okay, but I can't because I canceled out a factor. I canceled out that visual reminder that I can't use those values. Right?
So anything you cancel out.
Anytime you cancel out a variable, you have to look at when is that variable or the expression, the binomial, equal to 0. You have to add that restriction. Otherwise, you end up dividing by 0 as a possibility, and that can't happen. Right? So we have to add these little restrictions on there. Right? So when we do the dividing one, I'll put the restriction on it as we do it. Right? So that's what you're going to do when you multiply. All right? You have to factor, cancel common factors, and then you have to write what you have left. All right? And so when you cancel the common factor, what we can do is put up here, you also have to consider restrictions.
So when you cancel, they automatically become negatives in the last one? Why does it say
It's when the value is equal to 0. So you're saying, when is x plus 1 going to be equal to 0? You have to ask yourself that. So that when you solve it, so whatever the number is right now, it changes sign because it's going to move over to the other side of the equal sign. So we just do it mentally so we don't have to keep writing this. But yeah, that's what you're doing. You're basically changing the sign on it. Right? Yeah.
So in the first one, 3 would be a restriction because of no variable?
Yeah, correct. Yeah, so if you cancel out just a number, you don't have to worry about the restriction because there's never a time that number is going to be 0. You only have to worry about if it's a variable, and that's it. Right? Right. So then, here's what you're going to be doing when you're dividing. All right. So the thing you have to remember about dividing is that you first have to change to multiplication. So that's going to be your first part, is when you divide, I want to change to multiplication. All right, so you have to take the right-hand fraction and write its reciprocal, so that way you could change it to multiplication, and then everything else is exactly the same as all of the other examples above there. Right? So, for example, like 3x over 5 divided by 6x over 15. Right? You are not allowed to go through and just start canceling things, canceling factors, when you're across division. Right? So the first thing that you have to do is you want to change the division of the right-hand fraction into that multiplying by the reciprocal. Right? So I'm going to leave my 3x over 5 alone and change this to multiplying by 15 over 6x. And now you can simplify because now it's multiplication. It's almost identical to letter A. So again, you can take a 3 out of each of these and just leave the 2 down in the denominator.